We have the equation. We try to, okay, the starting point, it is ZL equals to 1 plus absolute value of the gamma times exponential J theta over 1 minus the absolute value of gamma times exponential J theta. Okay, this is the starting point, and we try to separate this one to RL plus JXL, and also we try to separate the gamma to gamma R plus J gamma I. The answer, if you separate the real and the imaginary part, you can finally obtain your RL equals to 1 minus gamma R squared minus gamma I squared and 1 minus gamma R squared plus gamma I squared. This is the real circle. Okay, this is what we try to understand. And also, there is another circle. It is an imaginary circle. XL equals to 2 gamma I over 1 minus gamma R squared plus gamma I squared. Okay, and this is the imaginary circle. You don't see it is a circle. It is because you didn't chance, you didn't organize these two. For the first one, you can reorganize and obtain. Actually, you can just see the answer of these two. For these two equations. For the first one, the center of the X shift. This is a position shift. And this is a radius for the circle. Okay. Because RL over 1 plus RL plus the same is 1 over 1 plus RL always equals to 1. This one means all of this circle will connect to this point. Okay. So this is the real part. And last week we know if it is infinite for the RL. Last week I try to ask you some questions, right? What if the radius it is infinite? If your RL equals to 0 or infinite or 1, what is the circle then, right? So if this is RL is 0, it means it is a short, because if this is 0, so the radius is 1. So this is this circle. So the red circle means RL equals to 0. Okay? If RL equals to 0, it means the center is at x equal to 0, y equals to 0, and this one. So the red one, the A, means it is a short circle. Okay? For B, if RL is infinite, if it is infinite, means the radius equals to 0 and it is infinite, means this one is 1, right? Gamma r minus 1. The center of the x will equals to 1 and y also equals to 0. So it means the circle at here, this is for this is B, for this B, this is not what I want to say. So this is this point. This is the infinite. RL is infinite, which is open. And then for first one, it is a short. Okay. And if RL equals to 1 means ZL over Z0 equals to 1. All the real part of that is 15 ohm. If Z0 is 15 ohm. For the third case, I put this is 1, 1, 1, right? So the radius is 0.5. Radius. And the position, it is also 1 over 2 equals 0.5. So this is this circle. Okay. Then come back to our Smith chart. You can see them again. So this is 1. So this is a circle of 1. Okay. And you can see the number is getting smaller and smaller to this is 0.1 and this is 0. Okay, so for the circle outside, for this circle, it is RL equals to 0. And for this one is 1.0, 1.2, and it's getting larger and larger. This is 10, this is 20, this is 50, and eventually, for this point, this one means RL goes to infinity. So this point is open. Okay, this is open, and this is short. It is funny that open and short, they are overlapped. Open and short, they are overlapped. For this point, this is also open, and for this point, this is also short. So open and short, they exist simultaneously on this point. It is weird, I know, but you need to remember it. Okay, this is for the real. real part. Let's go back to this is a real impedance. And also you want to see the imaginary impedance. If you take only the imaginary part, you will obtain these equations. Okay, this is we do everything the same, and you obtain this imaginary circle. And what can we do for an imaginary circle? You can see that all of the imaginary circle for this is we can see you can regard this like let me simplify this one. You see this like an X, and this is Y, okay? And you can take this is R, your radius. So on your on this map, all of the circle is at the position of x equal 1. Okay, all of the circle, the center all of these all the imaginary circles, it is on this. All of them, the center of them x equal 1. Okay, what is its y? Where is its y? The y, the center of y is always at 1 over xl. And the radius is also always 1 over xl. Okay? Which means all the circles, if the xl is positive, all of them is above this axis. All of them is above. I will use another of this circle. So all of them will connect to this point. Every of that, the center is always 1 over XL, if 1 over XL is positive. And for the opposite one, or if XL is minus, all the circle is here. Okay. Because we use the equation, we assume this one. This is a reflection coefficient. When you change L, this one will never change. The absolute value of reflection coefficient will never change. Only change the phase of that. So every position of the transmission line, at any position of the transmission line, the absolute value of the reflection coefficient is always the same. Only thing change is the theta. Okay, come back. So we can use the so all of you can bring your Smith chart. Okay, I already gave you an example about if I connect 100 ohm to 15 ohm and the transmission line, it is a quarter wave transmission line. What you need to do is at point A, it is here because 100 over 15 equals to 2, right? This is RL and the XL equals to 0. So just only one point. For this circle is, for example, let me give you a example, a question as an example. Can anyone tell me, everyone, you just take picture on your chart. I want to just ask a quick question. If the Z0 equals to 15, okay, 15 ohm, I connect this transmission line on 100 plus 15 J15 ohm. Okay, give me point A, just give me point A. So use your Smith chart to find point A, which is Z in, this is at 0, okay? Okay, this is a question. I give you three minutes, 2:55. I will close the question. Only some of you can answer. Find point A for me, please.
老师是在图上面做，然后把那个点找出来吗？
Yes. And take a picture, show me your answer is correct. Just only one point. You don't need to make a circle. We will make the circle later. This is how to use the Smith chart. One more minute. Hurry up. So, 修文张玉信、石凯生、林志兴。Okay, time is up. So, 曹德宇。谢国立、林典胜。Okay, that's it. 哦，玉祥，邱玉祥。Okay, that's it. So,
老师，我有教到。
but I didn't see. Oh yeah, yeah. Okay, 我看到。Okay. 许富阳。Okay. So the answer will be, because this is at this one, the normalized RL equals to 2 and the XL equals to positive 1, right? So you take this circle and also you find out where is the imaginary part for the imaginary circle. So you can get this one. Okay, this is the first thing you need to do to find out the point at A. Okay, this is the first thing you need to do. And later, the second part is you need to use a ruler. Use the ruler from not easy for me. Maybe you can find your ruler on your Smith chart. To check what is the beginning of the position is. Then you will find here. Okay, I hope all of you can follow what I'm doing now. Use your ruler to use it from the center of the circle through your starting point, the impedance of your starting point to get outside, okay? Then you will see a number. This is the number of your position. What is the number of position? It is 0.214. Okay, this is 0.21. You need to see the outside circle because you need to use the clockwise direction. This is 0.214, and the unit of that is lambda. Okay? Okay. So this is the starting point. And then you need to know how long it is. If it is a quarter wave transmission line, you just plus 0.25 lambda. Okay, for example, is 0.214, right? And use your compass to this one, and it is not easy for me to use that on iPad, so but you should also use that on the circle is weird. Use your compass. Use this number first and then add. Depends on how long your transmission line is. If it is a quarter wave transmission line, you plus the number to 0.25 will equals to 0.464 lambda. Okay. So find out the 0.464, 0.464 is almost there. Okay, and what you are going to do, use the ruler again. If this is a quarter wave transmission line, this one is always has the half circle, okay, to this position. But sometimes for my question, sometimes I will give you the answer about like a 0.3 or 0.4. Then your new position will change to some other place. It depends on the new number. This is the wavelength. And if the number is more than 0.5, you will use the new scale, okay? What you need to do is just abstract your number to 0.5. Okay, so for the outside of the scale, it's only, the maximum is 0.5 only, it's here. You will smartly use your new scale. Okay, and then go to the new position, and you use a circle. You use your compass. You make a circle to a new place, and then you find out what is your new impedance. The impedance here, the new impedance here, it is the impedance after the new length of your transmission line. Remember this new impedance, it is an impedance under the normalization. It is a normalized. So if you want to know what the impedance is, you need to multiply your characteristic impedance again. Okay? Let me give you a question. Okay? Let me give you a question, and I hope all of you can answer my question at the moment. Okay, I will use the same question. So if your load impedance is 14 plus J70, and your Z0 is 100. Yeah, I just close it. So wait. Wait a moment. Yeah. Please use your Smith chart to answer a question. If I have a load which is 40 plus J 70 ohm, I connect this to a transmission line. The transmission line has characteristic impedance Z0 equals to 100 ohm. The length of the transmission line is 0.3 lambda. So what is the beginning ZL? Show me this one on your Smith chart. This is for question 1. And also show me a new ZL at 0.3 lambda. This will be one of the questions for the final exam. Okay? Show me these two equations on your Smith chart and take a picture for me, please. And I will give you probably 10 minutes to answer my question. Okay, 10 minutes. Show me this question on your Smith chart. After 10 minutes, the question will close automatically. You will need to mark every important number on your Smith chart. You will need to mark every important information on your Smith chart to show me you understand how to do this. Hong Xiuwen, you need to give me the answer. What is the new input impedance? I didn't see a number.
老师，你说编号吗？
No, this is the impedance
哦
for
，OK，
1, right? What is the impedance for 2?
OK，
Please use your compass. Use your compass to make a circle. Every of you need to use a compass. For the you need to find out where the point is and then make a circle. Okay? And the circle give me the answer of your point 1 and the point 2, and give me the number of your point 2. Give me the answer point 2 and the non-normalized this one, and give me the answer.
老师，我传的
What is the starting point? And where is your transmission line? Where is your transmission line? At here and at here, and for each point, where are they? This is important. This circle is important. And on this circle, show me point 1 and point 2.
老师图片太大了，就是它会截图，会截掉。
其他人都有传啊，我要再放大这样子，就试着传吧。我只是要知道你会不会，到时候期末考的时候会要你们直接画在图上面交，所以不用担心，因为你们会实体来考。One more minute, please hurry up.
老师，我那个圆就只画2个点，我没有画另一边，这样也不算。
把它画完嘛，就是先做。你是不是没有圆规？
我有啊，我是那个圆，我就只有画左边的点到点，我没有把右边整个画完。
你就照课本先做完嘛。为什么要自己创呢？对不对？就照课本做。OK。OK， 时间到了哈。Okay, let's see the answer. Let's see the answer. So this is the answer. The The correct answer, you need to show me. You need to show me where it is. Okay. The normalized RL equals to 40 over 100 equals to 0.4, okay? And XL equals to 0.7. So you will find 0.4 circle and 0.7 circle, and this is your 0.1, okay? This is the first step. Second, you will use your ruler to make this line. Okay? And you will need to read the number here. It is 0.105. Is that correct? 0.105. Okay. You can check that on your Smith chart, 0.105. I know it is very hard to read, but this is just the classic method to use Smith chart to find the answer. Okay, you need to read this number. And you make a whole circle. The center is here. The radius is from the center to your point 1. You make a whole circle. You need to use your compass to make the whole circle. Okay, and you have this number 0.105. Then you add 0.3. So 1.105 plus 0.3 equals to 0.405. Then you find the number 0.405. It is here. Okay, this is 0.40 and this is 0.41. So you will make a new line from center to here. Okay, and this new blue line will intersect with your black circle, and the answer will be this. Okay, but it is not finished yet. What you need to do is to read this number. So what is the number of this? You will use this one. The real circle, it is, I think it is 0.3, maybe 8. And what is the imaginary circle? The imaginary circle of this one, it is 0.6. Okay, and what you need to do, it is unnormalized, it times 100. So it's probably 38 plus 60J. So what is the answer of that? I don't have the answer of that then you can check. What's your answer? So everyone's close because I use iPad. I don't have I didn't use the Smith chart to show that. But if you have the paper, you will have a more accurate answer of that. Okay, this is one of the things we need to do for Smith chart. And you get a new answer of that.
老师，为什么你是加 J60？
加 J 0.3啊？
它在下面不是减 J 吗？
因为是负的啊，它就是你要加西塔的话，它都是顺时钟转。你记得西塔等于 minus J to beta L 吗？你的西塔往上面是正的，所以它是负的，所以你的长度会是顺时钟 clockwise。OK？ 你记得你的西塔定义吗？是负 J 2 beta L。这个还是 OK 吗？
我想一下，
老师不是虚部吗？但虚部不是负的吗？在图的下面，图不是在下那个点。
哦，对。哦，我说错了，对。我知道史凯生在说什么，这个啦，对，没错。
对，
是负的，没有错。好，我不知道你们的数字跟我一不一样啦，就大概是这样做 ，OK 吗？那你们有没有答案？What is your answer？ 你们要给我答案哦。你们最后说出来是多少？史凯生是36减 J61，是不是？对，差不多。然后呢，江玉信你没有答案哦，有吗？江玉信 ，What is your answer？
那个是旧的，新的还没。
OK，so 谢博也没有哦，你是 normalize 的对不对？
我画错，就是0.106，我写成0.16，所以画错了。
你们，我只是说你们知不知道怎么做了？
知道。
好，那梁家凯也是一样哈，你有过去对不对？可是你没有画一个圆，你要有圆规，所以你一定要有圆规，期末考一定要有圆规，然后你要知道那个数字多少。邱玉祥好像对，可是你没有乘回来，对不对？邱玉祥你会了吗？
我会，就是没有乘100回去，然后
对。OK， 那彭浩你也是嘛？彭浩你会了吗？
会了。
OK， 好，那还没结束哈。There are more usage of the Smith chart because you make a circle, right? You make a circle. I didn't make it very perfect, but you will know the center of the circle is in the middle. There will be a radius R, right? This is the radius of this R is the reflection coefficient. This is 1 from center to this one. This is 1. This is reflection coefficient equals to 1. This is a circle for the open and also the short. Open is this point. Short is the outside the circle. Okay. So this is the gamma, the absolute value of the gamma. This is the radius. So, but after you make your circle, actually you have the length of this one, right? Then you will see under this Smith chart, you will see there is a reflection coefficient. And you will use think you can use this one, reflection coefficient. This is 1 and 0, okay? So what you need to do is use the ruler to copy the length of this one. And you put this line on it. Okay? Not mapping, you just copy the same length of that. And you can measure what is the absolute value of the reflection coefficient. Okay? You can also use this one. I think they are very similar scale. Okay. And after you have a reflection coefficient, you can also obtain your SWR. SWR. This is what we learned, and this is the scale. Also, if you want to know the reflection coefficient in dB, you can see this line. OK， 好，最后老师用中文再跟你提醒一下哈。刚刚的圈圈算出来以后，你就可以知道这个圆的半径。那这个半径的话，你用下面的尺，你就可以量它的 reflection coefficient， 就是它的那个反射系数的绝对值。好，它在上面绕，它的指会相位会改变，在那条线上面，只要它的 z0 是不变，好 ，zl 是固定的嘛，你唯一改变的是你的长度，你的 l， 对不对？所以在你的线上面，它的反射系数的绝对值都不会变，它唯一会变的是它的相位，哦，所以它永远都会在这个圈圈绕，那绕到多远，它就是新的点在哪里，它这个值不会变。你在 VNA 上面看到的值就是20 log 绝对值，所以这个数字就是你在 VNA 上面量到的这个 S11 的值，它都会在这边。哦 ，Smith chart 上面，如果你要去看它的你的 VNA S11， 然后呢那个频率的话，然后去看它怎么样。哦，这个图都不会变，你那个线一直变，就是如果你的线是固定的，好，线是固定的，它都不会变。然后，但是实际上它在 Smith chart 上面会变，它的阻抗值也会一直改变，但只是说它的绝对值，好，它的反射系数的绝对值是不会变的，这样。那你们这样 Smith chart 会不会了？哦，考试的时候会考你什么？会考你就跟刚刚的这一题是一模一样的，我会给你一个数字，然后你要画出来，然后呢？再给你一个长度，然后这条传输线的 characteristic impedance 是多少，会到一个新的值，然后会问你新的值是多少。哦，这一定是第一题。第二题会叫你用公式算，你要把公式 zin 等于多少带进去，然后把这些数字都带进去，然后这两个数字要相等。你要证明 Smith chart 跟公式是一样的，然后公式也会考你，这个伽马是多少。然后你要在史密斯chart上面读到的数字，跟我公式看到的数字读到的数字是一样的。这样有没有问题？没有问题的话，我们就再休息一下下，还有一堂课。好，我们再讲一下 Smith chart 的应用，好不好？我们休息，一样休息10分钟好了。好，42分回来，42分。